The Moivre's theorem, number one, right, we have to multiply these two together and then we have to divide them. Now, the Moivre's theorem states that what you do is you multiply the moduluses together, these guys, and you simply add the arguments. So we'll do that. So Z1, Z2 is equal to 2 times 3, which is 6. And that'll be the cos of pi upon 3 plus pi upon 4 plus I sine pi upon 3 plus pi upon 4. That's simple, and just tighten that up a bit. We have the cos of, it becomes 7 pi upon 12 plus I sine of 7 pi upon 12. Now with division, we divide the moduli, and we subtract the arguments. So we have that Z1 over Z2 is equal to 2 divided by 3. That'll be the cos of pi upon 3 minus the pi upon 4, plus I sine of pi upon 3 minus the pi upon 4, which becomes 2 and 3 outside of the cos of pi upon 3 minus pi upon 4 is pi upon 12 plus I sine of pi upon 12. Done. All right, in number 2, a little bit more involved with this one. We have to work out what this is. Now, what I've done here, I've used the Argand diagram to work out what the mod arg form is for each one. So 1 plus I, from here you can see, is going to be square root of 2 times the cos of pi upon 4 plus I sine of pi upon 4. And then you can see when you cube each one, I'll just do it this way. Okay, and cube that one there, and cube that one there. Now that becomes 2 root 2. But this becomes, we multiply the argument here, the cos of 3 pi upon 4 plus I sine of 3 pi upon 4. Right, now in a similar manner, we'll have that 1 minus I, or cube, or I'll just do 1 minus I first, and that gives me root 2. This will be the cos of, now it's minus pi upon 4, plus I, the sine of minus pi upon 4, and then we'll cube this now, cube that one, cube that one, cube that one. That becomes 2 root 2. This becomes the cos of minus 3 pi upon 4 plus I, the sine of minus 3 pi upon 4. Now what I'll do here, I'll rewrite that as, it's just the cos of 3 pi upon 4. But this one is minus I of sine of 3 pi upon 4. Now when we add these together, 1 plus I cubed plus 1 minus I cubed, we're going to have, this one will be 2 root 2 outside of, now adding these guys here, right, there'll be 2 of those, so it'll be 2 cos 3 pi upon 4. But here you'll see when you add those two together now, they'll go out, so it's just plus 0. And that's 2 root 2 times 2 times. Now the cos of 3 pi upon 4 is simply minus 1 root 2. Those root 2's will cancel out. You just simply get minus 4 as the final result. Done. In number 3, we're going to prove that z to the n plus 1 over z to the n equals 2 cos n theta. And we'll see an application of this in question 4. Now to do that, first of all, we'll say that z equals cos theta plus I sine theta, the modulus being 1. So z to the n equals cos of n theta plus I sine n theta. Now z to the 1 on z to the n is z to the minus n, which is the cos of minus n theta plus I sine of minus n theta. Of course, that is the cos of n theta minus I sine of n theta. Therefore, z to the n plus z to the minus n must be equal to, we add these two together, 2 cos n theta, and here once again these guys go out. So we have z to the n plus 1 over z to the n equals 2 cos n theta. And we'll be using that in the next example. Number 4. Given that z to the n plus 1 over z to the n equals 2 cos n theta, and by applying the binomial theorem, show that the cos of 4th theta equals 1 over 8 outside of a cos 4th theta plus b cos 2 theta plus c, and hence find the values of a, b, and c. Now first of all, let n equal 1, and we get that z plus 1 on z is equal to 2 cos theta. Now raising this to the power 4, we get z plus 1 on z to the 4th equals, this becomes 16 cos the 4th theta. Now we'll apply the binomial theorem to this, do the expansion of this one, and I'll do it over here, I think. It's a bit tight. At z plus 1 over z to the 4th equals, that becomes z to the 4th. Do Pascal's triangle up here so you can see it. 2 there, sorry. 1, 3, 3, 1, 1, 4, 6, 4, 1. So it becomes plus 4z cubed times 1 over z plus 6z squared times 1 over z squared, running out of room here, plus 4z times 1 over z cubed plus 1 over z to the 4th. Right, so this becomes z to the 4th plus 4z squared plus 6 plus 4 over z squared plus 1 over z to the 4th. Now we'll regroup. We get z to the 4th plus 1 over z to the 4th, put that in brackets, plus now 4 outside of z squared plus 1 over z squared plus 6. Now we can see that this is, from our formula, z to the 4th plus 1 over z to the 4th is 2, becomes cos of 4 theta, plus 4 times, now this becomes 2 cos 2 theta, plus 6, which becomes 2 cos the 4 theta, plus 8 cos 2 theta, plus 6. Now we know that z plus 1 over z to the 4th equals this. So we can say that this must equal this. So 16 cos the fourth theta must equal 2 cos the fourth theta plus 8 cos 2 theta plus 6. So that becomes cos the fourth theta equals, bring out the 2 over 16 into cos 4 theta plus 4 cos 2 theta plus 3. So A must have been equal to 1, B must be equal to 4, and C is equal to 3. Now the power of this thing is that you've got a power function here equals to a linear function. Later on, if you want to integrate these things, it's much easier to integrate that. So it's a very important rule. Done.